Hi there, welcome back to my channel. In this video, I'll be taking you through higher order derivatives. What are higher order derivatives? From our previous lessons, we've been doing find the derivative. Always, if they don't bring whether first, second, it means that we are doing the first derivatives. But higher means that we are going to do first, which is f prime, second f prime prime, third f prime prime prime, fourth f prime 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 prime. Or you can see the f, let's say the y over the x. This becomes the squared y over the x squared, the cubed y over the x cubed, d to the power 4y over the x to the power 4. These are the notations of what? Our higher order derivatives. So with this put down, how do we find the higher order derivative? I have an example here for us to solve. So higher order derivative means after differentiating, we keep on differentiating our resulting derivative until the number of orders are exhausted. So the problem here is we should find the third order, meaning d cubed y over the x cubed of the expression y is equal to x squared e to the power x. So let's see how we do that. So to do this, you realize that our function itself is a product rule, right? I have a polynomial function and I have an exponential function. So my first derivative dy over the x. So number one, my first is equal to, now I'll let u be equal to x squared, v to be equal to e to the power x. So my u prime is what? 2x. V prime is what? E to the power x. It doesn't change. So I'm going to have my u prime v plus v prime what? U, right? And what is u prime? 2x and my v e to the power x plus my v prime e to the power x multiplying my v multiplying my u, right? Which is what? X squared. So my first derivative dy over the x simply gives me 2x e to the power x plus x squared e to the power x. Now we want the third derivative, so I move on to the squared y over the x squared. For that reason, I'll take each of these and I'll differentiate as well. So for here, I'll move straight to simplify. I will differentiate, so I have two components, this and this, right? So I'll take my 2x separately and e to the power x separately. Okay, so to do that, so normally when there is a constant multiplying, this is what I will advise you to do. So this, you put the constant out, okay? Then here I'm going to get what? X alone and e to the power x, so that I can easily differentiate. So when I differentiate x, I'm getting 1. Then maintaining this e to the power x, right? 1 times this is the same thing. Now I'll maintain this and I'll differentiate x. Sorry, I'll maintain x and I'll differentiate this. It's still the same, like this. Then I come to this side. This side will give me 2x whilst e to the power x is there, then x squared e to the power x. So I simply get 2e to the power x, 2x e to the power x plus 2x e to the power x plus x squared e to the power x. So I can join this and this, and I'm getting 2e to the power x plus 4e to the power 4x e to the power x plus x squared e to the power x. And this is only for what? Our second derivative. So we should find the third. So the cube over the x cube, the cube y over the x cube, what would that be? I'll also take this and do that. So here is just a single function, so I get 2e to the power x, the same thing. When I come here, I'm having 4xe to the power x. Take 4 out. Then here you differentiate x, I'll get 1 e to the power x plus, I'll differentiate this, I'll get e to the power x, okay? Plus this gives me 2x e to the power x multiplying what? Sorry, plus I'll have e to the power x squared. So I'll get 2 e to the power x, sorry, 2 multiplying e to the power x plus 4 e to the power x plus 4 e to the power x multiplying x plus 2x e to the power x plus e to the power x squared. Now let's see. I have 2 e to the power x here, 4, and that is 6 e to the power x plus I come here. I have 4x e to the power x plus 2x e to the power x 6x e to the power x, and finally I have e to the power x squared here. And this is the end of the video. Don't forget to like, subscribe, and share.